Welcome back, physical science students, to our last video of the unit on states of matter. Today we're going to be talking about Boyle's law and Charles's law. This is going to relate pressure and temperature and volume. For our gases specifically, we're talking about our gases in this case. We do have a unit test, and then reminder that 1 week from Thursday we have our final coming up, and that all of your work is due Sunday, May 17th. Make sure that you hit that deadline for all your makeup work, and I will get it graded, and then we can go straight into the summer. But without further ado, let's get into Boyle's law and Charles's law. So let's talk about pressure first. Pressure is the amount of force exerted per unit of area, or pressure equals force divided by area. So if any of you have ever worked with pressure before, like air pressure in a tire or anything like that, you hear of things called pounds per square inch and things like that. And so that's just talking about the amount of force being exerted outward per the area that it's exerted on. Okay, so for example, a balloon and a bicycle tire are considered to be containers that are containing this air pressure. They remain inflated because of the collisions the air particles have with the walls of their container. So if you remember when we talked about the different states of matter, that solid, the molecules are really compact together. In a liquid, they get more fluid. And then in a gas, they are way spread out and they're bouncing around like crazy inside their containers. Okay, this collection of forces caused by the collisions of the particles pushes the walls of the container outward. So when you fill up a balloon, okay, you're not just filling it up with air, okay? Like if you don't just think about it as air, think of it as tiny little molecules going in there, and they are bouncing around on the outside of that balloon to actually keep it inflated. Okay, if more air is pumped into the balloon, the number of air particles inside of it increases. Okay, this causes more collisions with the wall of the container, which causes it to expand more and more until it can't take any more collisions and eventually ruptures. Okay, pressure is measured in a unit that we call the Pascal. It is the scientific unit for pressure. Okay, it's kind of like that we use meters for distance and liters for volume and that sort of thing. It's the standard unit that we use. Because pressure is the amount of force divided by the area, 1 Pascal of pressure is equal to 1 Newton. Remember that force is measured in newtons, and that we measure distance in meters. So this is 1 Newton per square meter, or 1 N divided by M squared. Okay, so Boyle's law. What happens to gas pressure if you decrease the size of the container? So think about this. I have a container and it's filled with air. Okay, if I shrink that container, what do you think is going to happen to the pressure inside? Hey, hopefully you said, if you squeeze gas into a smaller space, its particles will strike the walls more often, giving an increased pressure. Okay, so if you take a balloon that's really full and you try to smash it down, okay, chances are you're going to burst it because the pressure inside is too great. Okay, the opposite is also true. If you take something small that's filled with air, okay, and you increase the size, the pressure is going to decrease because the particles have more room to move around now. Okay, so Robert Boyle, a British scientist, described these properties of these gases. Okay, according to Boyle's law, if you decrease the volume of a container and hold the temperature constant, okay, so you're not increasing or decreasing the temperature, okay, the pressure of the gas will be increased. Okay, an increase in the volume of the container causes the pressure to drop. Again, in this case, we are keeping temperature constant because, as we know, if you increase temperature, then you can increase the movement of your particles, and that can cause something different to happen. So we're trying to keep temperature the same in order for Boyle's law to take effect. Okay, Boyle's law states that as pressure is decreased, the volume increases. So as you increase the volume, the pressure is going to decrease. Okay, here is a nice pressure volume curve that states as pressure increases as we go to the right, the volume has to decrease as we go down. So as I go left to right, okay, remember this is an inverse relationship. As one goes up, the other goes down. Okay, the opposite also is true as shown in the graph. As I decrease pressure, okay, the volume goes up. Okay, as I decrease the volume, the pressure goes up. Okay, as the pressure is increased, the volume will decrease. That is the big statement. Okay, when Boyle's law is applied to the real life solution, we find that the pressure multiplied by the volume is equal to a constant if the temperature is constant as well. Okay, meaning that we can use math to solve these problems for us with a very, very simple equation that you guys are going to have to know how to use. Okay, so you can use the equation P1 V1 equals P2 V2 to express this mathematically. And so all that means is that the initial pressure and the initial volume is always equal to whatever the final pressure is times the final volume. Okay, so if we start out with, let's say the pressure is 5 and the volume is 10, okay, 5 times 10 is 50. No matter how I change the pressure and volume on the right side, it always has to multiply to 50. So I could increase the pressure to 25, but then the volume would have to decrease to 2 because 25 times 2 is 50. Okay, so let me just write that out real quick, just so that you can get an idea of what I was talking about. Okay, so if I start out with, let's say, an initial pressure of 5 and a volume of 10, okay, and let's say that I want to increase the pressure, okay, so that equals 50. Let's say I increase the pressure to 25. Well, that automatically tells you that the volume had to be 2, because I know that 25 times 2 is also 50. These two numbers always have to match up. Okay, the initial pressure times the initial volume always has to equal the final pressure times the final volume. You can't get some different value when you're doing this equation. Okay, what happens if you heat an enclosed gas? The particles of the gas will strike the walls of the canister or the container more often. Okay, if the pressure becomes greater than the canister can hold, it will explode. At a constant volume, an increase in temperature will also increase pressure. So notice that it's very important that we keep the temperature constant when we're talking about Boyle's law, because an increase in temperature can also increase pressure, and we don't want that to be the reason that our pressure is increasing. We only want to compare it to the volume. All right, so then we have from Boyle's law, we have Charles's law, which was and Jacques Charles was a French scientist who studied gases as well. Okay, according to Charles's law, the volume of a gas increases with increasing temperature as long as pressure does not change. Okay, so now we're taking kind of part of Boyle's law, and now we're applying it to temperature. Notice that Boyle's law compared pressure and volume. Now we're comparing pressure and temperature with Charles's law. So keep those two things straight. Boyle's, pressure and volume. Charles's is going to be pressure and temperature. In a very similar way, okay, they're going to be very, very similar. Okay, so as with Boyle's law, the reverse is also true. So if you look here, we have temperature and volume. You'll notice that as temperature goes up, so does volume. So this is a direct relationship, whereas for Boyle's law, it was an inverse relationship. So as temperature goes up, volume goes up. As temperature goes down, volume will go down. Again, remember, this is keeping pressure constant. Charles's law can be explained using the kinetic theory of matter. Okay, if you remember very back to when we started states of matter, this is the first thing we talked about was the kinetic theory. Okay, and that all of the things that exist, okay, are made up of these tiny particles that are constantly moving. Okay, and if you imagine things that are heated up move faster. So as a gas is heated, its particles move faster and faster, and therefore its temperature increases. Okay, and therefore its pressure also increases, and the volume of the container that needs to hold it has to increase as well. So because the particles move faster, they begin to strike the walls of their container more often and with more force. Okay, this is why in a balloon, as you keep in a hot air balloon, so think about a hot air balloon, as you heat it up with the fire, okay, it inflates the balloon because it heats up the air particles that are in the atmosphere, causing them to move around more sporadically, filling up that balloon and allowing it to float. Okay, the formula that relates the variables of temperature to volume shows a direct relationship between temperature given in Kelvin, make sure it's in Kelvin, okay, and the volume. Okay, so the initial volume over the initial temperature equals the final volume over the final temperature, or in other words, sometimes they use I's and F's. VI over TI equals VF over TF. That just means volume initial, temperature initial equals volume final over temperature final. If you relate it back to Boyle's law, it could be V1 over T1 equals V2 over T2. Okay, they mix and match those subscripts to basically mean the same thing. Okay, again, this is another equation that you're gonna need to be able to use. When using Charles's law, remember that the pressure is always kept constant. Okay, so let's get this example problem done with using Charles's law. What I would recommend is that you pause the video real quick, take a look at my problem here and try to figure it out. Excuse me. Do remember that your degree Celsius will have to be converted to Kelvin in order for this to work. So without further ado, I'm just going to get straight into it. So we have here, what would be the resulting volume of a 2-liter balloon? Okay, so liters is always going to tell you volume. Okay, at 20 degrees Celsius, that's going to be your temperature. Okay, temp, and then 3 is also going to be a temp. Okay, and these were, so obviously we're looking for the resulting volume. If you remember, the equation is V1 over T1 equals V2 over T2, or VI and TI and VF and TF, whichever way you want to think about it, it doesn't really matter. Okay, so if I set this up correctly, 2 liters must be my initial volume. My temperature, my initial temperature is 20 degrees Celsius, but I need to convert that to Kelvin. And the way that you do that is very, very easy. You just take that number and you add 273 to it. And that's going to tell you that your Kelvin is 293. So I'm going to sub that in, equals. Now V2 is what we're solving for because we're trying to find the resulting volume. I'm going to place X in place of that. Okay, and then for T2, my final volume is 3. So 3 plus 273 is 276. Okay, so if I put a 276 there, now I'm just solving for X. You'll notice I have 2 fractions that are equal to each other, or 2 proportions that are equal to each other. So I think back in geometry, you learned to solve these by either cross multiplying, or if you have some other way that you solve these things, use that method. But in this way, 276 is being divided on the right. So if I multiply it to the other side, okay, I get it out of the denominator. 293 is in the denominator on the left. If I multiply that to the other side, I get it out of the denominator. And when I do that, 276 times 2, just off the top of my head, let's see, 2 times 200 is 400. 2 times 70 is 140. And this is going to be 552. Okay, if you need a calculator, use your calculator for that. And then I have 293 times x, which is just 293x. Okay, lastly, to get x by itself, I'm just going to divide by 293 on both sides. Okay, and the result, I'm going to go over here. Your math teachers would be disgusted by my organization here, but that's okay. Okay, and I'm going to get that 1.88 equals x. Now, what I want you to always go back and do when you're talking about these laws is, does it make sense? So I started out at 2 liters and 20 degrees Celsius. If I decreased my temperature according to Charles's law, I should decrease my volume. And you'll notice that I did decrease my volume from 2 to 1.88, and make sure that you always include units. It should be 1.88 liters. Okay, so make sure things like that match up when you're doing Boyle's law and Charles's law. And to be honest, guys, that's all I have for you. There's a little practice with Boyle's law and Charles's law, and then the unit test that you need to complete. And then we'll get into our next unit talking about nuclear chemistry. We'll talk about nuclear bombs and nuclear power plants, and then we'll get straight into the final after that. If you have any questions, make sure that you reach out to me, come into office hours, set up a time with me if you're struggling. Other than that, thanks for watching.